Here we have a data center network deployed by CloudVision. There's currently 2 spines with 2 racks deployed, each with a pair of top-of-rack leaf switches. We also have some existing EVPN services provisioned, including VNI 10.101 shown here. Now we are going to scale out this data center by provisioning a new rack with the leaf switches 7A and 7B. Using CloudVision Studios, we are going to create a workspace, which is our staging ground for preparing these network changes. First, we need to accept the changes learnt by CloudVision Studios as the new Leaf 7A and 7B devices were added to the network and registered with CloudVision. This includes the new connections learnt on the spine switches. We confirm the 2 new switches were added to the Studios inventory, ready for further provisioning actions by Studios. The data center already deployed by Studios is defined in the L3 leaf spine studio. Our DC1 has DC pod 1 in place, and we are going to add 2 new switches. We create a new leaf domain 3, and add the 2 new switches into that leaf domain. That's all that's necessary to deploy the new leaf switches with the required underlay and overlay configuration to join the fabric. In this case though, we are also going to deploy a new EVPN service to the fabric as part of the same workspace. Within the Corporation A tenant, we are adding VLAN 103 and providing the necessary VLAN configuration parameters. We're using these text fields here in the UI, but these inputs can also be programmatically assigned, for example, having an external system populate with the IP addresses from an IPAM. For devices, we are going to configure the tag query role leaf. This means that all devices in this network with the tag role leaf will be configured to consume this VLAN as proposed as part of this workspace. We see the list of devices that match this tag query, and we select the devices we want to apply this service to. This includes our newly deployed Leaf 7A and 7B switches. We also see some BGP tags here and parameters for the existing switches, which will get defined for the new leaf switches by Studios as part of adding the devices to the L3 leaf spine studio. There's nothing for the user to complete here. This interface allows the user to deploy this EVPN service to other parts of the network, not necessarily deployed through the L3 leaf spine studio. We're also going to modify an existing VLAN deployed, VLAN 102. This VLAN is currently only deployed to leaf domain 1, however we also want to enable in leaf domain 3. The tag query provides us with great flexibility in defining a logical grouping of devices to deploy to. Reviewing the workspace results in the build process running, which shows us the studios and tags modified, validating the inputs provided by the user, compiling the resulting configlets for each device affected, and validating that config against the devices. With our new service definition VLAN 103, the common config proposed for the existing leaf switches is shown with the new config in green for each switch. Leaf 7A and 7B have additional config to deploy as part of the changes proposed in this workspace, and their changes are shown here, which includes the necessary underlay and overlay config to connect to the fabric. The spines of course receive new config to enable the connectivity to the new leaf switches, which is shown also. We're happy with this, so we will submit the workspace, which saves the changes to mainline code and prepares a change control. Another opportunity to review the changes if required, but otherwise approve and execute the changes. This change control is executing the tasks in parallel, which we could stage these by grouping tasks or serializing them if we prefer. On completion, the new switches have been added to the data center, provisioned with the services we've defined. And we also have those changes to the existing switches as we've proposed with the service changes. Drilling into Leaf 7A, we can look at the VXLAN table to confirm the VLANs deployed 102 and 103. And we can get a high-level view of the services deployed in topology view, showing VNIs created between the switches, shown here with the dotted lines. So with that, we've successfully scaled out our data center network using CloudVision Studios.